In this question, a ball of mass m moves with speed u at an angle a to the horizontal. So that's going to be u cos a in the I direction. And in this case, it looks like it's going down in this direction here, according to the diagram. So positive and negative in here, minus u sine a in the j direction for before. Afterwards, after impact, it moves with a speed v at an angle b to the horizontal. So we're going to have a v cos b in the I direction. And it's going to, we'll imagine it's going to rebound up this way according to the diagram. Positive, positive. So plus v sine b in the j direction. So show that the coefficient of restitution E, which you have seen in the previous question, is equal to tan b over tan a. Well, what can we say here? We can definitely say that u cos a is equal to v cos b, because the I doesn't change. We can also say that after, which is v sine b, over before, which is minus u sine a, is equal to minus e. So if I cross multiply here, I'm going to get v sine b is equal to e u sine a. Now the proof might not be as obvious as it seems, but if we take this equation here and divide this one by it, and we line up our b's, so I'm going to put this guy on the left, so I'm going to get v sine b divided by v cos b. So I'm dividing equation 2 by equation 1, so u cos a is going to go on the right, u cos a. You can see here the v's cancel, the u's cancel, and we're left with sine b over cos b, which is tan b, is equal to e times sine a over cos a, which is tan a. So therefore e is equal to tan b over tan a, which is what we were asked to show. A ball of mass m in this question, it moves horizontally with a speed of 20 towards a smooth barrier xy, which makes an angle of tan inverse 4 over 3. So let's just do the tan first. The inverse of the angle is the opposite over the adjacent, given a 5. So cos a is 3 over 5 and sine a is 4 over 5. And that's what the horizontal, the coefficient of restitution here is 3 over 4. Find the speed of the ball after impact. Okay, so let's look before here. Now it looks like the diagram, it looks like should we just have I going on here, but I think it was better off imagine it coming down in this direction and hitting here. It says it's moving horizontally, but we just changed the diagram around to have this bit being our x-axis, and then we can do it this way. So if we say before, we're going to have u cos a, and we have u being 20, so 20 cos a in the I direction, and it's going in a positive negative direction, so that'll be minus 20 sine a in the j direction. So 20 by 3 over 5 is going to be 12i, and 20 by 4 over 5 is minus 16 in the j direction. So now we have after over before is equal to minus e minus this 3 over 4. So 4x equals 48. So x is equal to 12. So now we have 12i plus 12j for after. And we are looking for the speed afterwards. So the magnitude of 12i plus 12j is going to be the square root of 144 by 2, or 144 plus 144, which is the square root of 288 meters per second. And that's what's that, 144 by 2, 12 root 2, 12 root 2 meters per second. The magnitude of the impulse due to the impact. So the impulse is equal to mv minus mu. So let's have a look at what's going on here. The vector. The mass is m times v, which is after 12i plus 12j. And then we have minus m times before was 12i, just double check, minus 16j. So this is going to cancel the 12 IM and the minus 12 IM, so you can just write out here 12 M in the J direction. We're going to have plus 16 M in the J direction, so the magnitude of the impulse is what we're asked for. The impulse is 12 M in the J plus 16 M, so the impulse is 28 M in the J direction, and obviously the magnitude of 28 in the J direction is going to be 28 J and in Newton seconds. The loss in kinetic energy, so what's happening here, we've got our speeds, we had root 288 and we didn't do the other one, did we? The 12 and the 16. So let's have a look at the loss in kinetic energy, a half mu squared. So at the start we have a half times m. 12 squared is 144 and 16 squared is 256. So if you want to put them in, 144 plus 256, that's 400. Half of 400 is 200. Afterwards, a half mu squared is going to be a half times m, and we had the 288, didn't we? We already have worked that out. That's going to be 144. 200 minus 144 is going to be 56. And if I put my m's back in, it's going to be 56 m joules. And then the last part, the tan of the angle between the ball's new path and the horizontal. So we've turned it around so that this is our horizontal. So now the ball rebounds off, let's say, in this direction here. And afterwards we had 12i plus 12j. So let's look at that angle here. That's going to be in here. B. So at the inverse tan of 12 over 12, the inverse tan of 12 over 12 is just going to be 45 degrees, isn't it? 45 degrees. So this one is 45. This one here, the inverse tan of 4 over 3. The inverse tan of 4 over 3. You could use a trigonometric ratio here, tan A, tan B, or tan A plus B. That's going to give 53.13 degrees. And if I add those two together, I'm going to get 98.13 degrees, 98.13 degrees, and the inverse tan of 98.13 degrees. I've rounded it off slightly, but that's going to give me minus 7.40, so minus 7.0000 before I get any numbers. So the answer here to the tan of the angle between the ball's new path and the horizontal is minus 7.